On a hot day, opening a refrigerator feels like opening a box of winter air. Cold air spills across the floor, so it seems reasonable to leave the door open and cool the whole room. For a few moments, the air near the refrigerator may feel cooler, but after the machine runs for a while, the room becomes slightly warmer, not colder. A refrigerator is a heat pump. Its job is not to create cold. Its job is to move heat from one place to another. Inside the cabinet, a refrigerant passes through an evaporator at low pressure. As the refrigerant evaporates, it absorbs energy from the food, shelves, and air inside. That is the cold side of the cycle. The compressor then uses electrical energy to squeeze the refrigerant vapor. Compression raises its pressure and temperature. The hot refrigerant flows through coils, usually on the back, underneath, or within the walls of the appliance. In those condenser coils, it releases heat into the room and becomes liquid again. An expansion device lowers its pressure, and the cycle repeats. With the door closed, this arrangement makes sense. Heat is removed from a small insulated compartment and discharged into the much larger room. The refrigerator also releases the electrical energy used by its compressor and fans as heat. The room warms a little, while the sealed cabinet remains cold. Now open the door. The cold compartment and the room become one connected space. The evaporator removes some heat from room air that enters the cabinet, but the condenser returns that same heat to the room. On top of it, the refrigerator adds the energy consumed from the electrical outlet. The total heat released into the room is therefore greater than the heat removed from the air. The thermostat makes the result worse. Warm room air continually enters the refrigerator, so the appliance senses that its interior is too warm. The compressor runs for longer periods. More electrical energy is converted into heat, and that heat remains in the room. The open door may create a local cool draft, but the whole room energy balance moves in the opposite direction. This also explains why a refrigerator needs ventilation around its heat-rejecting surfaces. If the condenser cannot release heat efficiently, the compressor works harder, energy use rises, and components run hotter. The exact clearance depends on the appliance design, so the manufacturer's installation instructions matter more than a single universal gap. An air conditioner succeeds where the open refrigerator fails because its hot side is outside the room. The indoor coil absorbs heat, while the outdoor unit rejects that heat, plus the compressor's electrical energy outdoors. The boundary is the key. A machine can cool a room only if it transports heat across the room's boundary or stores it elsewhere. So the cold air from an open refrigerator is real, but it is only one part of the cycle. Once all the energy is counted, the refrigerator returns the removed heat and adds its own operating energy. Leave the door open, and the room pays the difference as extra warmth.